Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're going to do probably a pretty long series of videos about building this Elekit TU-8888 push-pull monoblock amplifier. I'm not going to talk about critiquing anything in this series. We're just going to be building it. So let's get busy putting this thing together. Okay, so I'm going to start the build with the main board because to me it's the place that you're most likely to make a mistake and that you need to be the most focused. You want to make sure that you put every part on the board exactly where it's supposed to be and the right orientation and everything else. You don't want to rush through this part. And I feel like if you do some of the other steps first, you're going to be like, okay, let's get going. So I think while you're fresh, and don't try to do this while you're tired, make sure that you're like focused so you can do this correctly. Because again, this is where mistakes are going to happen. First thing you want to do is put all the resistors in the board. They're the least sensitive as far as heat of any of the components you're going to be putting on. And as you can see, there's a bunch of them. Now some of these brown resistors are audio note ones that Victor includes as an upgrade. And so you may or may not have those. You may be working with just the base kit. And in that case, you're going to have these tan resistors. But we're going to be putting these audio note tantalum resistors in the signal path. And so you got 5 bags of resistors. You got a couple of resistors in this bag with these two little blue caps. And then we got these resistors. And then you got this note from Victor on where the expensive resistors go, which are all in the signal path. And then we got our instructions. So the main thing we're going to be working with, let me get that page out and put the other ones to the side. And that's going to be this list right here that has all the resistors that go on this main board and where they go with a checkbox marked next to them. But before we do these general resistors, I'm going to do this list first, and then we're going to mark these resistors off of this list after we put them in place. So do this list first, this R1 through R6, and then R14 through this whole list here. So again, first we're going to do these lists here and put these audio note resistors in. Then we're going to come back and cross off those resistors using this number off this list and then continue on. Now, one of the things that they're showing, and I don't agree with this, but it's just not how I do things. If you look here how they show to put the resistor, they're showing to put it flush up against the board. I just don't think that's a good idea. I like keeping a small air gap underneath the resistor where it's not against the board. There's plenty of room. There's no reason that I know of to stick the resistor just up against the board, because resistors, no matter how small or how little current going through them, are going to have some heat on them. And so you want that heat to be able to dissipate. And so I'm going to be spacing them off the board just a breath so that there's an air gap underneath them. So, what tools are you going to need? First of all, you're going to need some flush cutting nippers, and I've been using these, what are these things? CP? I'll put the link in the description. I've been using these for years, and I've got 2 pairs of them, and they've lasted like virtually forever. They're still sharp as when they were new, and they're inexpensive. So I would highly recommend getting this brand with these red and black handles. The other thing you're going to need is some wire strippers, and same brand. These go from 16 gauge to 26 gauge. That's a good range for working on tube amps. And so you want to get a pair of wire strippers too. Obviously you need some solder. He supplied some this WBT silver solder, which works fine. I like this thinner gauge solder for working with circuit boards. And if you don't get his kit and you need some solder, I really like this MG Chemicals 6040 solder that's got the RA flux. It flows really well, it's easy to solder with, and this is what I build most of my stuff with, but either one will work. Then we have the measurement tool, and I highly recommend, I mean, you don't have to, these resistors are probably fine. You can go by the color codes on them. A lot of people are colorblind or don't even know it, and I think it's a safer bet to use something like this for an RC LCR meter. It's got a little place here that you can put the components across. It's a pretty inexpensive tool. It's handy just to have anyway, and it lets you double check all the resistors individually before you put it in the board. Like if you're doing all the 47K resistors, you can put them in here and then put all the 47Ks in a little pile and then put all the 47Ks in the board. And then you know when you're done that there were no bad resistors, they were all within spec, and you put them in the right place. So there's no second guessing if something isn't working right, going, I wonder if one of those resistors, you don't have to go back and check it. You've checked them before you put them in the board. And so that's just how I work. And of course you need a really nice soldering iron. I use this Heiko iron that I've been using for a long time. It's an ESD safe soldering iron. It's a nice little station. I think they're under 150 bucks still, and I don't have a special tip. I just use the standard tip that comes with, and it works fine for me. Even with this, isn't what I call fine circuit board work. This is pretty big stuff. It's not like we're dealing with surface mounted devices and that sort of thing. So you want a good soldering iron. The other thing nice to have is some jeweler's needle nose pliers. They just come in handy for holding stuff and bending stuff and doing that kind of stuff. So there you go. I do also have a 5.5 millimeter wrench will come in handy. I've got a snap-on one. You don't have to spend the money to buy one of those, but I really enjoy good tools, and so I've splurged and got a little set of snap-on. They call them ignition wrenches, but a 5.5 millimeter wrench fits the standoffs and stuff, and it'll make life a little easier. You're going to need a screwdriver set, a nice Phillips head screwdriver, and also we'll go over this in just a second. Let me get these resistors out of the way. So one of the things with this is the main board here in the middle, and then these are the different power supply boards. They have one for 100 volts, one for 115 volts, and one for 230 volts. And then this is the little board that the RCA jack gets soldered onto, and also for the input trimmer potentiometer if you're going to use it. I'm not using it. I don't want to put anything in the signal path that I don't have to, and we're going to be driving this with a preamp anyway, and so possibly if you were going to try to not use a preamp and you were okay with, sticking a screwdriver in the back of each of the amps to set the volume, that just doesn't seem like a good idea to me. I didn't see a good place to put a volume control on it anywhere else, and I just decided I'm going to use a preamp to drive this. So in this case, we're going to solder this little pad here, which we'll go over later, and just leave this potentiometer out. But it's a handy way to put the RCA jack on the back. So we're going to be using that little board. these are the two boards that go. These are the two boards that go on the output transformer, and then these three here are related to the speaker jacks, and then this is the board for the meter. So what they show is just putting this across the edge of a table and snapping these off. And while you can do that, that feels a little risky to me on a kit this expensive of potentially damaging one of the circuit boards. And while I'm sure they wouldn't put in the instructions if it's okay, when I tried to do it, it seemed like it was really flexing the boards. And so I've got a Dremel tool with a little cutoff wheel, and I'm going to be using that to cut these little attachment points to separate the boards. And then I'm going to also use this to trim off the excess, which you're going to have to do if you snap them off across the edge of a table anyway. So basically, you want to be careful that you don't cut the traces, because you could ruin one of the boards with this thing if you're not careful. And I would just use it on the low speed and just go like this. Okay, and then once you cut it off, we want to trim off these little nubs that are left over. Let me zoom in here and show you what that looks like. So it's going to leave these little rough nubs like that. And so then we're going to come in, and probably easier to do it from this direction. See, and then now you got a nice smooth edge, and that way you make sure that you don't have a rough edge that you're dealing with. So let me cut one more of these off just to kind of show you how this works. So now we have this whole section cut off, and we'll cut this one off, and I'll show you smoothing the edge again. And there you go. And you can see we got a nice smooth edge there, and no risk at cracking the board. Again, just be careful. If you decide to snap them off, that'll work too, and you can get some sandpaper and sand that down. But that's just how I did it. So let me separate all these boards, and we'll come back and start working on this assembly. Okay, so we got the board all separated out, and we're ready to start working on it. Got my soldering iron nice and heated up. And people ask me, what temperature should I solder at? And that's kind of like asking people, how do you like your haircut? I mean, everybody's got different opinions. I like a really hot soldering iron that I keep clean. The problem with running a really hot iron is the iron gets dirty faster, so you have to clean it a lot more while you're soldering, but I feel like you can get in and out quicker, and you have less dwell time on the joint. and the solder flows better. So I run 750 degrees on the iron, and you can use whatever you want, but people ask me what I do, that's what I use. So anyway, this is a single-sided board. You can see all of the circuit traces are on the bottom side. The deal to understand about these kind of circuit boards is all the parts go on the top, all the soldering happens on the bottom. There's no traces or any flow through. These don't even look like they're through plated holes, so there's no point trying to flow solder through them. Yeah, I can see they're not. So you're just trying to connect this pad to the joint or to the device. And so you just lay the bead on there. The real trick to it is you want to make sure that you've got the tip wet. And what I mean by wetting the iron is you get a clean tip that you've just cleaned off with your sponge or your Brillo pad like thing, and then you touch it with some solder. That wet spot right there is where the heat will transfer. This other side that's kind of dull looking, you can put that against something for 5 minutes and it's not going to melt solder. It's that little puddle on the tip that lets you heat up the part and solder. So anytime that you put the iron up against something and the solder isn't melting into the joint pretty quickly, just stop, clean the iron, get a little puddle started like that, and then put that puddle up against the pad and the pin. You want to heat them both up together and then feed some solder in till you get a little mound there, and then stop. You want to make sure too that the part doesn't move after you've heated it up, because that's how you get a cold solder joint. So the next thing we're going to be doing, that's probably a pretty good zoom right there. And then we may zoom in closer when we're working on specific points. We're going to start with this list here. So we're going to get our 220K resistors here. These are the audio note ones. So we're going to get one of these out, and then I go ahead and bend it like this. And actually, I may just leave this zoomed in. It's probably a little better for what we're doing. So then we get our meter powered up, and we stick it in our little part steel. And we switch it over to ohms and 220. And for people that think you're going to see like 220.00, that's not going to happen. And it doesn't need to be that critical with tube stuff. And so this is like what you can expect to see. 219, even 218 to 222, and that kind of range is perfectly fine. Nothing to be worried about. So we tested that. Let's go ahead and test this other 220 while we're working on our 220 ohms. When we pop it in and 220 as well. So now we know we got 220 ohm resistors. If you bend them ahead of time, then you know that these are tested resistors that are sitting out. And I would definitely do like one value at a time. Like do all the 220s that are in this list. And then when you go to the next list, do all of the 220s together and not jump around or try to do, well, I want to do R1, then R2, then R3. I would not recommend doing that. So we come over on this side of the board, and the numbering sequence on this board, it starts over here in this corner and then kind of works its way down and then across here and then over into this corner. And then it kind of works its way clockwise around the board. Like here, that you can see, these are the ones in the 40s, and then the higher numbers are here. So it starts, like I said, it starts over here in this front corner, and then it works its way clockwise around the board. So when you're hunting down a resistor number, that's how you go. So this is R1 is a 220K, and people work different ways. Some people like to just put all the resistors in the board and then go back and solder everything all at once. I like putting in the resistor values that I'm working on, solder those in, clip the leads off, and then it gives you more room to work. So there's R1, and then the next one, if we get something here, we can see that R6 is the next 220K. So let's look for R6. There's R5. There's R6 right there. So put this guy in, and then like I said, I leave just a little air gap underneath them. I mean, if you want to, you can just put them right up against the board like the instructions say, but that's not how I like soldering. And then since I'm leaving a little air gap, I want to put something under the edge of the board so that it doesn't push the resistors up against the board. And then we're going to solder these two guys in place. So let me get my solder here, and we wet the tip, and then you lay that puddle right up against the pad and the lead. Just like that. And then we'll do this guy up here in the corner. And then we'll have our first two resistors soldered in. You can see that didn't want to melt. And so come back, wet the tip, put that wet tip in there, bead a little solder in, because the flux is in the solder. And if you don't feed a little bit in there, you can't just like put a puddle of solder up there and then hold it up against the joint, because there's no flux. The flux is in the solder. And I've seen some people solder, they want to put a little flux on each joint and then just come in and do that, where they put a little blob of solder on the iron and then touch it into the flux. I don't like doing that. So then, once you've done that, you come back and trim the two leads off. And then, one thing I do, which I know some people are going to think is really silly, I like coming back and then just doing a little touch like that, and a little touch like that, and then you don't see the cutoff part and it looks nice and smooth. I know that's being crazy anal retentive, but that's how I like soldering circuit boards. And so then, once we've done that, we come in here and we get our marker and we mark off R1. Actually, it's probably smarter to mark off this side over here. Go like that. And then we know we can go on to this other list. And you don't have to do this as you go along, but you could if you want to. Is come in here and we've done R1 and R6. And mark it off that list so that you've got those two marked off, and you know you don't need to install those. So I'm going to populate up the next value and solder up some more stuff. Well, I hope you're enjoying this build series. If you are, please subscribe to the channel. Please like the video. I got this kit from Victor Kung at VK Music up in Canada. I'll put the link below. And as always, DIY audio is fun. So until the next video, have a nice day.